Hello, this is Aditya classes and I am Manish Tamar. Today we will be taking a question or rather numerical of line balancing. So you might have gone through other numericals on line balancing. Today we will take a numerical where the network is not given, rather some relationships are given, precedence relationships are given. So here we have our question where the precedence relationships are given. For my sake, I will put this question on the board also and then we will continue. So here is our question. I have written it over here for my reference. Now the situation is, first we need to construct a network of relationships between the machines given from 1 to 10. Their preceding tasks, the preceding machines, preceding jobs are also given as these. We need to design an assembly line to produce 40 units in an 8-hour shift and 24 units in an 8-hour shift. So there will be two questions. We will be designing that shift for two different scenarios. Now, first thing that we need to find out over here is cycle time. Which is given by total time upon number of units. So in our case, total time is 8 hours. Let me convert it into minutes upon total units. Why are we converting it into minutes? Because 8 upon 40 would have been very small and it would have been tough to sequence or prepare an assembly line. So let me convert it into minutes and then we'll get some good tangible integer numbers. So what do we get? Here is our cycle time of 12 minutes. Now what does this 12 minutes tell me? It tells me that every workstation that I'll be designing will be of 12 minutes. Now before we can get on with designing of workstations, first we need to design our network of relationships. Now network of relationships, remember the networks are different in case of PERT CPM and as in case of line balancing. The major difference is that in case of PERT CPM, those are activity on arrow. The arrow signifies the time consumption. When you are on the arrow, that is the time when an activity is going on. That is the time when time is being consumed. Whereas in case of assembly line balancing, the activity is written on node. We have arrows, we have nodes. So in PERT CPM, we made use of activity on arrow. Here we used to write 4 days. While in case of assembly line, we make use of activity on node. The processing, the time consumption is going on node. Whereas in PERT CPM, the time consumption was going on in arrow. So that will be the difference. Major difference we need to keep in mind when we are drawing. A lot of students I have seen get confused when constructing a network for PERT CPM or for assembly line balancing. So these are clearly different. One, progress is on arrow, the time consumption is on arrow, while in this case time consumption will be on node. So how do we go? And these are relatively easier to construct. We have 10 machines. Obviously, who is the one without predecessor? First machine is the one without any predecessor. It is not waiting for anyone. Who is the preceding task? None. So one is waiting for no one. So one can start straight away. We can have our one over here. Then 2, 3 and 4 are waiting for one. All these tasks are, all these machines are waiting for the material to come from 1. So we will be having 2, 3, 4. So we have 2, 3 and 4 over here. Then 5 is getting its material from 3. So we can say that 5 is getting its material from 1 will be giving material to 2, 1 will be giving material to 3, 1 will be giving material to 4. 5 is getting its material from 3. So 3 is supplying to, acting as a source for 5. 6 is getting material from 3 and 4. So we have 3, we have 4. 6 is getting material from both 3 and 4. 7 is getting material from 2. 7 is getting material from 2. 8 is getting material from 5 and 6. 5 and 6 both are supplying material to 8. 9 is getting material from 4. 9 is getting material from 4. 10 is getting material from 7, 8 and 9. 7, 8 and 9. So we can have 10 over here. Here is our network. So this is a network of relationships between these 10 machines. How is the material flowing? Now what next? We can have our durations written over there. On machine 1, processing worth 5 minutes goes on. Second is this is how it goes. So we had our network. For first question we needed 40 units in 8-hour shift. So we found out our cycle time. Here is our network of relationships. Now the second step. We are doing the first question. We found out the cycle time. We constructed the network for it. And third step would be finding out waiting times, waited times. So we have our cycle time. Second step is our network of relationships. Third is find waited times. What are waited times? If you have gone through the other videos, you might have seen that waited time is time taken from any particular machine to reach the last machine. For example, if I take machine 6, so what is the network, what are the paths, what are the arrows, what are the machines that will be touching from 6 when we go to 10? If you see 6, there is a flow to 8, then there is a flow to 10. 9 is not related to our flow. Nothing is coming from 6 to 9. Yes, they are connected through 4, but then that will be a reverse flow. From 6 to 4 would be a reverse flow. So 6 and 9 are not connected. So we can leave it over here. Then if we talk of 5, yes, 5 and 8 are connected, but then that again becomes a backward path. So again 6 and 5 we can say they are not related. Similarly, if you talk of 7, 7 and 10 may be related, but 6 and 7 are definitely not related. So in a sense, if you wish to understand what machines the material will be flowing through, imagine that this is a network of transparent pipes through which water is flowing. Transparent pipes through which water is flowing. If I put a drop of ink over here, if I put, let's say, blue color ink over here, so where will that blue color ink flow? It will flow through this. Now because water is coming from 5, it will not flow in reverse direction. So my blue coloring will not flow here, my blue coloring will not flow here, not flow here. Blue coloring will flow only through this 6, 8 and 10. This is how we can identify that the flow is from 6, 8 and 10. What happens to the flow from 3? If we talk of 3, how is the flow? From 3 to 6, from 3 to 5. All these activities Weighted time will be a summation of all these activities for 3. Why? If I put a drop of ink over here, first of all it gets distributed in these directions. Then it follows this path, and on 8 it will combine and move to 10. So we can see that how do we identify what will be the remaining machines, remaining processing. Summation of all those times from remaining machines will be our weighted time. For example, what will be the weighted time for 10? We'll put the weighted times in squares so that we could differentiate. What will be the weighted time for 8? Now if you see, only one pipe is flowing from 8 to 10. There is only one flow from 8 to 10. So if you put a drop of ink over here, it will only flow in this direction. So 8 and 10. This is the network involved. 9 minutes and 6 minutes. So what will be the weighted time for 8? It will be 15. Now let us say what will be the weighted time for 6? From 6, if we put a drop of ink, it will flow only in this direction. So only these activities are engaged. 6 and 3, 9 and 9, 18. Now we can find out weighted times for all other machines also. For example, for 9 it will be only one flow, 9 and 12, 21. 5 it will be only one flow, 9 and 6, 15 and 6, 21. If we talk of 3, this is one path, there is another path, so it is getting distributed and then combining. So all these activities counted once. 9 and 6, 15, 15 and 6, 21, 21 and 3, 24, 24 and 7, 31. Then what about 7? Only one path is going, 9 plus 4 would be 13. Then what about 2? Only this sequence. So 9 and 4, 13, 13 and 3, 16. What about 5? 5 we see that it is getting distributed over here, then it is following this path. So we can go ahead and add these two paths. 9 and 6, 15, 15 and 3, 18, 18 and 12, 30 and 5, 35. So we have weighted times for all, and weighted time for last, it is not required, but still we can find out. From 1 there are so many paths. So from first machine, in a sense, if you add complete time, that will be my weighted time. Because anything, a drop of ink over here will pass through the complete network. Wherever you may go, it will be coming from 1 ultimately. So the weighted time will be an addition of all. Or we can go ahead and add these all. 9 and 6, 15, 15 and 3, 18 and 6, 24, 28, 28, 40, 50, 55 and 60. It was not required. Weighted time of first and 10th are not required exactly, but still we can find out for practice sake. So this is my third step rather. First step was find cycle time, construct network, and now I found out waiting times. I'll put that step over here to make it easier to understand or to recall. We are attempting the first one. Step 1 was cycle time. Step 2 was network. Weighted times. And last step is design assembly line. So now we are on to our last step. We'll leave these A, B and C out. So we're through with these 3 steps. Let us move on to the 4th step. How do we proceed with 4th step? We have workstation, eligible jobs, jobs or machines or whatever the question or numerical or it tells remaining time. So these are the 4 things that we need to keep a track of. Now let me start my first workstation. When I start a workstation, how much time do I get? I get time equal to my cycle time. So I get 12 minutes. Now because nothing has been assigned, the complete 12 minutes are still available. Now let me go for assignments. Now which machine can I process on? Can I directly go to machine 9? Can I directly go to machine 3? Probably it is not possible. First I need to go to machine 1 because 9 will be waiting for 4, 4 is waiting for 1. If you go to 5, 5 is waiting for 3, 3 is waiting for 1, 5 is waiting for 3, 3 is waiting for 1. So everybody ultimately is waiting for 1 in some way. So we'll start our journey with 1. The first task to be assigned will be 1. The eligible jobs right now are only 1. This is the only eligible job, 1. So when this is the only eligible job, what I do is I assign that job to my assembly line. Now 1 will consume how much time? 5 minutes. 5 minutes are consumed out of these 12. So I am left with 7 minutes. Right now my first workstation was sitting idle. I checked my assembly line. I found that the only job that can be done or the only machine that can start processing is 1. I assigned that machine to my first workstation. Now this machine will take 5 minutes of processing. So this workstation has now 7 minutes left because 5 minutes of processing has been taken off. Now when this first task is done, how much time is left? 7 minutes is left. As soon as first is done, which are the eligible jobs? 2, 3 and 4. Now how do we check eligibility? I'll put step 5 also and then we'll free up this space. Efficiency of assembly line. Now what is the criteria for eligibility? Who will be the eligible jobs? There are 2 criteria if you have seen in other videos. First is preceding tasks should be assigned. For 9, 9 is not eligible because 4 is not assigned yet as yet. 4, for 4, 1 has been assigned. So I can say that 4 is eligible but 9 is not eligible. Why is 9 not eligible? Because 4 is not assigned as yet. But 4 is eligible because it is dependent only on one task which is assigned. So preceding tasks are assigned. And the second condition, remember these are not or, these are in and. First condition and second condition. Time required should be less than or equal to time remaining time. Now let me see. On first condition, this is assigned. So anybody who is waiting for 1 is now eligible. Who is waiting? 2, 3 and 4. All these are eligible according to first condition. Next condition is in and. Both conditions should be met. That time required 3 minutes, 7 minutes and 5 minutes. So second machine needs 3 minutes. I have 7 minutes. Time required 3 minutes should be less than time available, time remaining. So yes, 2 is eligible according to both criteria. What about 3? Preceding task is assigned. First is a tick. Second, time required 7 minutes should be less than or equal to time available. 3 is also eligible. Similarly, 4 is also eligible because 1 is assigned. Time required is 5 against 7. All these 3 are eligible. What do we assign first? We assign first the task with highest weighted time. Highest weighted time task is 4. 35 is the highest weighted time. So who gets assigned? 4 gets assigned over here. If I assign 4, it will consume 5 of my minutes, leaving me with 2 minutes. Now I can say that this has also been assigned. Fine. So I have assigned 4, 1 and 4. Now as soon as 4 is assigned, we can see that 6 and 9 look like being eligible. But on close analysis, we see that 6 is still not eligible because 3 is due. So as soon as 4 is assigned, we assume that 6 and 9 might be eligible, but 6 is also waiting for 3. Along with 4, it is also waiting for 3. So 6 is not eligible exactly because 6 has 2 arrows incoming, of which only 1 has been done. But 9 looks like being eligible. So on first condition, who are eligible? 2, 3 and 9 are eligible. On second condition, time required should be less than time remaining. Time required is 3, I have 2 minutes. So 2 is not eligible. Time required by third task is 7 minutes, 2 is remaining, not eligible. 12 minutes, 2 minutes, not eligible. So I can shut this workstation and I can now start my second workstation. Why? Because none of the eligible jobs according to first condition fit in second condition. So I cannot assign anyone. So that is a deadlock. And in order to overcome this deadlock, what I do is I start up a new workstation. As soon as I start up this new workstation, who is eligible? 2, 3 and 9. 2, 3, 9. All are eligible. Two, 3, 9, all are eligible. And what is the criteria for assignment? The one with highest weighted time, 16, 31, 21. 31 is the highest. So 3 will be assigned. Sorry, not here. 3 will be assigned. How much time does it consume? 7 minutes, leaving me with 5 minutes. So now I can see that this has also been done, this has also been done, that this is also done. Who is eligible now? As soon as 3 is done, 5 is eligible. We were talking of 6. 6 was waiting for 2 arrows from 3 and 4. So now 6 is also eligible. 5 is eligible. 6 is eligible. 9 is eligible. Even 2 is eligible. So on first condition, all these are eligible. 2, 5, 6, 9. But on second condition, time required should be less than or equal to time remaining. I have 5 minutes. 9 needs 12 minutes. Out. 3 minutes can be done. 6 minutes. Out. I cannot perform this task in 5 minutes. It needs 6 minutes. So 9 is out, 5 is out. This is still in, this is still in. So who are the 2 eligible jobs? 2 and 6. Of these, which will be assigned? The one with higher weighted time. Higher weighted time is with 6. It is 18 minutes. Well, in the second case, it is 16 only. So who is winning the game? 6 is winning the race. Consuming 3 minutes, I am left with 2 minutes. 6 got assigned. So I have 1, 4, 3, 6. 1, 4, 3 and 6 have been assigned. Now what is the scenario? You have 2 minutes left. If you check the eligibility, none of these require 2 minutes. Everybody needs more than 2 minutes. So I can close this workstation. I can start a new workstation where I again get 12 minutes. And who will be the new eligible ones? 2. Due to 3, this 5 is eligible. Due to 4, this 9 is eligible. Is 8 eligible? 8 is not eligible because 8 is getting its inputs from 5 and 6 and 5 has not yet been assigned. So our eligible jobs are 2, 5 and 9 on first condition. What about second condition? Second condition is time required should be less than time available. I have 12 minutes available. They need 12 minutes, 6 minutes and 3 minutes. So can I go ahead and assign them? 2, 5 and 9. Eligible jobs are 2, 5 and 9. 2, 5 and 9. Weighted time 21, 21 and 16. So we could go with either of these. Now if I look carefully, it is better that I go with 9. Both are 21. If I go with 5, I'll be left with 6 minutes. Fine. In those 6 minutes, I could have performed 3 this task. In those 6 minutes, 9 cannot be done. So what I'll be doing is I'll be assigning 2. Now I'm leaving out a task with higher weighted times. My priority should be to clear out tasks with higher priority time. So what I'll do is, instead of clearing this, I'll try to clear the longer task so that it is through with it, so that we are through with it. 9 consumes 12 minutes. We are left with no time. When there is no time, let us close this workstation. Let us start a new workstation. Now 9 is assigned. Now as soon as 9 is assigned, one might feel that 10 is eligible, but no, 10 is not eligible. It is getting inputs from 3 different positions. So we are through with 1, 4, 3, 6, 9. 1, 4, 3, 6 and 9. Now who are eligible? 2 is eligible, 5 is eligible. 8 is not yet eligible because 5 is due. So only 2 are eligible, which is 2 and 5. Higher weighted time is with 5, 21 minutes. So I am assigning 5. It consumes 6 of my minutes from this, leaving me with 6 only. 5 is done. Now as soon as 5 is done, 8 also is eligible because 8 is getting inputs from 5 and 6. So now I have eligible 2 and 8. Earlier it was 2 and 5, 5 is done. Now I have 2 and 8 on first condition. Preceding tasks are done. But what about second condition? I have 6 minutes. It needs 6 minutes and 3 minutes. So I'll go with 2 and 8 and one with larger weighted time, that is 16 will be assigned. So I get 3 minutes are consumed. I am left with 3 minutes. Now a logical point over here would have been that if I had gone with 8, no time would have been wasted. But if we are following this particular algorithm of weighted times, then we need to stick with our rules, and the rule is higher weighted time goes first. Logically, 8 would have made a better sense over here, leaving me with no wastage of time. But I am going with this. Now why am I closing this workstation? Because none of the eligible jobs can be performed in 3 minutes. Let me start my 5th workstation. I get 12 minutes to start with. And eligible is 7 and 8. 7 and 8 both are eligible. Who is going first? 8th is going first. Because of this weighted time, consuming 6 of my minutes. 8 is also done. 10 is not eligible as yet. 7 will go first. 7 is the only eligible jobs. We assign 7. It consumes 4 of my minutes, leaving me with 2 minutes. Now I have assigned almost all jobs, and 10th needs 9 minutes, which I do not have. So what I'll do is I'll start a 6th workstation with 12 minutes remaining. And the only eligible job right now is 9. We assign 9. It consumes, the only eligible job is 10. We assign 10 and it consumes 9 of my minutes, leaving me with 3 minutes. Now we can say that all tasks have been assigned. All have been assigned. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. All tasks have been assigned. What is the efficiency? Fourth thing was efficiency of assembly line. What is the efficiency of assembly line? What was my design time? I had 6 workstations, each workstation capable of performing task of 12 minutes. So my total time, design time is 72. 12, 24, 36, 48, 60 and 72 minutes of design time. What is the consumed time? Consumed time is whatever time we have consumed. How much time we have consumed? 60. This becomes my efficiency. Can we solve it? We can solve it using .33%. This is my efficiency. I had a capacity to work for 72 minutes, but my design has restricted me to working only for 60 minutes, and this comes as my efficiency. So this was how we can prepare an assembly line for 40 units in 8-hour shift. Now as far as this second bit is concerned, 24 units in 8-hour shift, I leave this task to you. You can start this numerical fresh and solve it for 24 units in 8-hour shift. What will be the differences? If we do it for 24 units in 8-hour, what will be the differences for us? 9th is worth 12. The network will be exactly same because network is coming from here. The differences will start coming in from this point. Our cycle time will be different because total time available is still 8 hours for 60 minutes each. But this time I need number of units. Last time it was 40, this time it is only 24. So we can say that my cycle time this time is 20 minutes. So this is where the difference comes in. Where does this difference play? When you start workstation 1, you get 20 minutes as compared to 12 minutes in our earlier case. So this is where the difference comes in. You can go ahead and assign these. This will be a practice problem for us to design an assembly line with 24 units. Fine. So that was it, where we are given a relationship. First we need to construct a relationship out of the table, and then when we have our network of relationships, then we can proceed in the similar fashion as we have solved the assembly lines in earlier cases. So that was it for today. Thanks for watching. Bye bye. Take care.